Today I'm going to talk about the Azure IoT Suite, setting a little bit of context on Azure IoT in general, and then dive a little bit into the IoT Suite itself. So I'm Sam van Houten, CTO at Coldit. So this is actually the first time that we use this floor. Normally we are on the second floor, we still are, but we just grew to this third floor as well. So welcome here. So we are based in Belgium, France, Portugal, and Switzerland since last week as well. And we focus on Azure solutions, and also that includes a lot of IoT. So, who of you has seen Azure IoT Suite presentations already? Okay, not that much of people, so that's good. I'm planning to do too much deep dive here. I want to spend, a good overview, and the positioning of Azure IoT should be good. Who of you has been, looking into IoT solutions or architectures already? Yeah, that's interesting. So what you typically see is that, and this is not depending on technology, but it always starts with the devices, of course, and you have different types of connectivity. Some devices are powerful enough to know where the cloud is and to send data or to listen for commands. A lot of times they go through a gateway where you have multiple sensors, for example, in a building. These sensors would be too expensive if you would have every sensor directly connected to the cloud. So typically they go through a gateway, and that could be the building management system, that could be something else. So that's a very common pattern as well. And a lot of times you have cloud gateways, and I will be talking about that as well. So that's a lot of things where you have the connectivity from the device to the cloud. Of course, the ingestion side, that's where you have the need for, getting all the loads of data inside. And if you have multiple devices, I'm not talking about hundreds, but thousands and of course millions, this has to scale very well. So that's why cloud is a very common architecture to use for IoT, of course. As soon as you have your data in the cloud, that's where the real value is built. That's also where you will be talking about intelligence, about streaming and things like that, where you process the data and you get the value out of that. So that's all the things on the right. And of course, you have presentation and connectivity to the end. So Azure IoT Suite tries to add some samples and some components in every one of these settings. So in general, there's a lot of confusion. So you have Azure IoT Suite, and you have Azure IoT Hub, and you have Azure IoT Services. You should say that Azure IoT Suite is just built on top of Azure IoT Services. I will be showing most of them. So again, it all starts on the left, where you have your devices, either connected through a gateway, directly connected, or connected through an API or something you host in the cloud. You have your field gateway and things like that. But typically they all send their data to, for example, IoT Hub. And also since yesterday, IoT Hub was general available. So that means it's now no longer a preview thing. 70% of the rest of Azure is preview, but that's at least GA. And if you've attended my session from, I believe, last year on event hubs, you will see the similar patterns there. So where you have, the scalability, where you can ingest all that data to the cloud. But what's added here, and what was not there in event hubs, is that you can also send from here directly to these devices. Of course, that's not an easy thing. If you have your device in a network, or in your home, if you have a ventilation system, a solar panel, typically they don't have a public IP address, of course. So you have to know that. It's not that they will have a direct connection there. It's a bidirectional communication pattern, typically AMQP or MQTT as well since today, that are supported to have a firewall-friendly connection, so that you can, from the cloud, send to that device in the field without having some kind of VPN or public IP address and so on. So that's all of these capabilities are foreseen by IoT Hub. If you've seen Service Bus in the past, Relay or Service Bus messaging, a lot of things are similar there. So it's like a good combination of event hubs and Service Bus messaging wrapped now in this service of IoT Hub. And the big difference is that every device has its own identity. So that's also important. If you have thousands of devices in the field and one of them is corrupted, someone hacked it or whatever, you can easily disable that one device and all the rest will be unharmed and keep processing data. So that's also important. You have different policies you can set per device. Things that will be added later on based on the roadmap, with no details there, is cloud-to-cloud communication. I'll be talking about that a little bit later, because not every device will be sending directly to the cloud. A lot of devices have their own cloud. This, for example, is LoRa. You might have heard about LoRa in Belgium. You also have Sigfox, which is from France and is also spreading all over Europe. But these things, you don't have to install or connect anything. The minute you buy them, they are automatically connected. It's like a GSM. So they connect through the Proximus masts or something. They are directly calling home and sending their data. Very minimal data, very low frequency. The most maximum so you can have is once per 10 minutes. So it's typically more for alarms or just status updates. It's not for big loads of data. But they just run on batteries, which is very nice. We have customers that just have this installed in their fridges. The fridges where they need to store meat, for example, they have this installed and it will run for a long period, up to 8 years. And the good thing is that this just sends data to the cloud, not our cloud yet, but the LoRa cloud or the Sigfox cloud. And then you have cloud-to-cloud communication, so that you need to connect from those device-specific clouds into the Azure system, because that's where we want to have our data. And typically that's just through an API push. So as soon as an event comes into their cloud, they push it into an endpoint that we provide to them. Okay, but I'll talk about that a little bit later as well. As I said, this is GA since today. And one of the things that was new with that GA was the MQTT support. So Microsoft has always been pushing AMQP. There's a lot of debate whether you should use AMQP, which is a little bit more heavy on the protocol side, versus MQTT, which some people argue might be a little bit less secure and so on. But at least now both are supported. It's also important to know that MQTT is typically backed by IBM, so you have some political things in the back as well. So as soon as you have these things, what Microsoft also did was open source some agents. So these agents, you could look at them as SDKs that you can use on your different platforms. So you have, we have a customer who's now trying this one, the real-time OS SDK, but you can do it on Linux, on Windows, Android, and of course it's based on standards. So if you have your own AMQP stack or your REST capabilities using HTTPS, you can of course just connect through these things because they are standard-based. So it's based on standards, but these agents and applications will make things easier to work, and you could consider them as a best practice. So that's why it says it's easy to use, but it's not a requirement. And they will be able to help send data to the cloud and again listen for commands. Okay. Now, as soon as that data enters the cloud, that's where the real value starts, and that's where you have things like batch analytics. I think Tom did a session on Cloud Brew on Data Lake. So where you have Data Lake storage and Data Lake analytics. You could compare that with batch analytics mostly. You have the machine learning aspects, so where you can do predictive analysis, other things like maintenance and peak detection and things like that. What you also see is the hot path analytics, so where you have stream complex event processing, where Azure Stream Analytics is, you could look at it as a more light, out-of-the-box platform as a service offering from Azure, which has a very low barrier to entry. It's just SQL syntax, and I'll show a little bit of these things later on. And of course, you have Storm and Spark, and that's a good reason why we have this second session later this evening. And of course, you might have seen sessions from Eve on Service Bus, on Service Fabric. So Service Fabric is one that we see that if you have more complex solutions where it's not just taking data in and storing data for analytics, where you need to do real complex business logic, that's where Service Fabric is very interesting. So one of the nice concepts you have is the actor framework. So the actor framework is something that, for example, in Halo, that's one of these famous Xbox games. I believe that every character in every game that is played worldwide is an actor in the Service Bus cluster, a Service Fabric cluster of the Xbox team, and they are like single-threaded executions. So what we sometimes see in architectures is that every sensor of a building could live as an actor, and that the room where he is in could also be an actor, and the building of that room could be an actor, and that way they can communicate virtually with each other. And if the room says, or if the building says, shut down all lights, which is an easy one, all the actors could send their comments to the right, could make the mapping from the software to the real physical thing again. So that's a nice concept where you can do nice, stateful things as well. And if you then move again to the right, it's all about presentation. So Power BI is a very nice one to get quickly started. It has its limitations and it has its power, that's for sure. And of course, we have BizTalk Server on this because that's what we have been doing for the past 15 years. But also logic apps and things like that. So what you see is that an IoT solution is never something that you should look to be on its own. It's always integrated with the backend systems. If there's an alarm from something that is in a corrupt state, someone needs to know about that. And a lot of times that's by creating a ticket in the ticketing system, or the maintenance team needs to know about things and so on. So that's where you have the integration and the visualization to the right. That makes sense so far? That's these components are all separate services you can use. So IoT Hub, Stream Analytics, it's all things you can use separately. In the IoT Suite, tries to combine them into one reference architecture, I will call it. Okay? So that's where the IoT Suite now enters. IoT Suite on its own is not adding new capabilities. It's more, it's like wrapping all these different services and providing you a reference architecture that you can use to build further on. Sometimes, if you talk to people of Microsoft, they will get the impression, or try to give you the impression, that Azure IoT Suite is something that will make IoT easy for you. I'm not here to say that that's true, because it has its limitations. I'm looking at it as a nice reference architecture that you can use, you can look into, it's open sourced, you can take it as some best practices, and then you still have to customize or at least do your own things. Huh? But it tries to do these things, it's built on the IoT Hub, so you have the connectivity and the scale, some basic analytics, that's full processing, and integrates with their business processes. But if you look in the code, it says not implemented. So that's something you need to do yourself. So it foresees in connectivity and management, data ingestion. Command and control is a nice feature there. It does the stream processing, predictive analytics, and using machine learning. Workflow automation is something that you can, link with it. It has a nice, interesting real-time dashboard that I will show. And it comes with pre-configured solutions. So you have remote monitoring, which is probably the most common one. And if you look into customers and they need IoT, what you see, they always start with, we have data or we have devices in the field, we need to know what's going on. We sell solar panels, we need to know how they are used. We do, you need to know what's going on. And that's remote monitoring. Later on, you might see things like predictive maintenance, where you have more analytics based on the historical data that you've done and on the real-time data, and you want to automate things. But I'll talk about that later on. So what I'll try to do now is first do the hello world thing, and I'll try to create an Azure IoT Suite thingy. So what you need to do, you can just go to AzureIoTSuite.com. And I hope the Wi-Fi is doing well because it's on the second floor. So you log in with your credentials. I would say for your Azure subscriptions, it's a wise thing to use your organizational account by now, because a lot of things are no longer supported with Microsoft accounts. And then you can see it can load the existing solutions that you have deployed for yourself, and it can create a new solution. And as you can see here, I have predictive maintenance as a template, and I have remote monitoring. So let me show you what would happen with remote monitoring. The only thing I need to enter is a solution name. Maybe I should add code it to make sure that it's all unique. And then you enter the region. As you can see, it's only available in 3 regions now. Let's take North Europe, which is, I believe, Amsterdam? No, Dublin. And then you select your subscription, so your Azure subscription. That's the only thing you need to do. And then you click OK. In the meantime, it shows what will be generated. So it will generate for us an IoT Hub. Again, that's the ingestion, the device registry, stream analytics. So 3 jobs will be created. A document DB, which you could look at like a NoSQL database. It creates a storage account that's for web jobs and for web site, and an event hub. I will show these things in detail. And you just click create solution. It takes a few minutes, and you can follow the process. In the meantime, this is one that was already created here, the IoT, called it /IoT one. So we can be a little bit patient, but yeah. Also, if you click on details, there you can see what he's doing. So he's creating Active Directory settings and things like that. So that takes a few minutes, and I will have everything normally created in my subscription. So what you need to know, everything behind the scenes is just standard services that I've shown before on the schemas, and they just get published in your subscription, the one that I created. It's all in the same resource group, so that's easy also if you want to delete things, because a lot of times this is used for trying things and looking at things. You create it and you can very easily delete it, and you're not paid for it. So a very common question is, how is this priced? It's just the price you pay for these services. So, and I will give you a little bit tips throughout the presentation where you can save some budget, especially if you look at this for trying things out and playing and not using it in production. So the first thing you will see in your portal is that you have a set of devices that you can create. By default, a lot of devices are created out of the box. Maybe one of the things that I should show first, because as I said, I will focus mostly on the remote monitoring, but I also created the other one, the predictive analytics. I'll just show that one. I won't dive into the details there. But that's a nice simulation with an airplane and some engines that get simulated there. I hope I'm getting logged in easy. Any questions so far? Please say yes. No, that's fine. So that's the portal that gets created for the predictive analytics. I haven't looked into it too much, so I don't know really in detail what's going on. But what you can do is you can start a simulation, and then machine learning is used behind the scenes to do, to test simulations against and you see the graphs for the different sensors. So again, this is not an end solution. This is not something that Boeing will be using suddenly to have its airplanes tested, but you can look at it as something nice, some nice things you can get from it as inspiration and as ideas. Okay. If you would look, because all of this is open source, if you would look into this specific one, you will see what's going on. You will see that there's jobs that it's also sending data to Hub and things like that. Okay, but again, the details on this one are not clear because this is the newest one, and it's also the one that I haven't played with yet. And as you can see, that's the state of the provisioning of my Azure setup. But if you go back here, what you can see, this is the standard portal where you can create devices if you want. So what I will do, I will try to create first a device. And then you have the choice between a simulated device or a custom device. If you want to connect your physical device or a software simulator that you built your own, the one you should pick, the custom device. This is one that you can very easily test. Create a simulated device. You give it a name. That's your device ID, Azure simulation device, or let's call it 01. So it has these things. It creates a device key. That's a key that will be used, or that I can use to send data on IoT Hub. So the ingestion side. That's a key that I could use to deploy with my device. A key that is specific to that device. And you might know this tool here, the Device Explorer. That's an open source tool on GitHub. And I will change that key afterwards, of course. Here, Azure simulation. So you see that the device has been created on IoT Hub specifically with that primary key. So the device could be sending data here. If you dive into the details, you will see that Azure simulation is still pending, right? That's because the device, I stopped all the jobs. It's a simulated device, so what does that mean? That there are some jobs, web jobs, that will behave as a simulated device. So it's just for demo purposes. That's not something you would use in production. But I created a simulated device. If I start these jobs now in my portal, in the Azure portal, of course, and if I go to the resource groups, you will see that I have a called it IoT resource group, and that resource group contains everything that was created by the wizard. So it contains the IoT Hub, it contains the document DB, and I will dive into those details. So if I now start the jobs, that's storage, right? I know that I attached them here, so let's do it through the shortcuts of my portal. So here I have two web jobs. That I will now just start. One is the device simulator, and let me zoom in. You should believe me. So the simulator is on the right there. And the other one is for event processing. That's for the alarms. So I will start both of them. And I can get a green icon. So now the simulated device is now sending data to the IoT Hub. The next thing I need to do is start these stream analytics jobs. Of course, normally they are on by default, but it's just to show you that how things are going. Because if I look into the dashboard here and I do an F5, I will still see that this device is pending. If I now do a start of the device info job, let's do a custom one from 5 minutes ago, and I'll start this one. Yep. Then I'm expecting to see that the device, Azure Simulator, in a few seconds will become as a live device. It's still pending, so that might be because of the telemetry job. So that's the 3 jobs, and I will talk about them in detail shortly. Again, 50. So I'm starting these 2 jobs. And I was expecting at least that this one should be events are getting entered. The good thing is that I have this one from this afternoon already, so I always have a backup when things would go flaky. And in the dashboard, I'm expecting to see various devices. And for example, this is the simulated device that I have, and normally that will send data. So here we should be able to see the lines of temperature and humidity, unless if it's this one. That's very nice. Anyway, I will show a real simulated device in a few seconds or minutes, and you will see that things will work. So now it's probably something with the web jobs that's not going as it should be. I'll get back into that. But what you've seen now is that there is a simulator that is running in the cloud that can send simulated information to the IoT Hub. That's the ingestion side. We have stream analytics jobs that process the data to here and here. So to storage for the monitoring and to event hubs for alerts. I will all show these things in detail. You have the web job, then you have DocumentDB. That's every device lives in DocumentDB as with its metadata, and then you have big apps for connectivity to the end. So if you now dive into the details. As I said, there's DocumentDB. So DocumentDB, that's the NoSQL store, where every device that I have here, and I count 9 devices. If I go to my DocumentDB store, there's one created for me, the Azure one, and the one that I'm using here. If I then go to the details in Document Explorer, every device now results into one document here, and that's just a JSON document. So it's a document with a structure that is defined, and this should be the last one that I just added. And you can see it's Azure Simulation 1. Status is true, so it just took some time. If I will go back here, you can see Azure Simulation is now set to true. So it was all a matter of time, I think. This, for example, this line is one that is now sending, but only every 10 minutes. So that's why you see it's not a very active line. And this should be the device like this, the Azure one, with just simulated data. So this data is generated by that web job. But it's not real data, it's just for visualization, for testing. In reality, we'll just throw that thing away, that simulation job. But at least you get some, you don't have to write code to see how things behave in the portal. So if I go back to the device, as you can see, they are live. And everything is here stored as metadata in these things. What's also there, let's see if I can zoom. What's also there is a set of commands. So every device, and that's what they do here, as soon as the device comes live, the first time it sends metadata about itself. It says, hey, I am a simulated device, and these are my set of commands that I know. So it knows a ping, it knows a start telemetry, a stop, change set point, and so on. So it says, this is the types of device of commands you can send to me. And they are just stored here, and they will be used by the portal and I will show that. It also has a history, comment history, of all the comments that have been sent. That's also all in the same document. And it shows that it's a simulated device and so on. Okay, so that's the device store you have as the backend for things like this, like the grids. And if I now click on comments here, you will see these comments popping up that were just in my JSON. Device, start telemetry, and so on. If I just change something, a new comment, I don't know, brew some beer, type of string, and I save this one, and I do an F5. I hope they don't implemented caching. You can see there's brew some beer, and I can enter the type. So that's the way that this portal lives. It looks into the repository. It sees this is device X. Device X has these comments, and I can execute them with these types of parameters. Okay. So that was the document store. So it has the device metadata, the comments, and the comment history. That's the most important things. You use this at the customer, the same model, because I think it's quite okay, but you can easily extend it with custom data. So you can easily add extra properties in this one. That's the flexibility of a NoSQL or DocumentDB database. You don't have to create new tables and things like that. Now, the other thing was the IoT Hub. So where you have the ingestion, identity of devices, the comments you can send. So as I said, every device exists as an identity on the IoT Hub. So the only thing that an IoT Hub knows about the device is its name and its key. All the rest of metadata, like its thermometer, its things like that, that's all stored in that DocumentDB. So IoT Hub is just a registry with an identity and a pair of secret keys and a state, of course. You can say it's enabled or disabled. And then every device has an endpoint where it can send its telemetry data, and it has an endpoint where it can listen for commands. So I briefly showed this tool already. So you can see here, if I do a refresh, that those are stored here with a primary key, a secondary key. Or they connected or not. What's their last activity time, or they enabled. So that's the only data that is kept over there. And I will show you later on if they are, maybe I can do that now with this simulated one. So it's still sending data. So I should be able to listen now with this tool as well on the Azure simulator. So this tool has nothing to do with the Azure IoT Suite. This is just a development tool that you use for IoT Hub. So if I now start monitoring it, I'm expecting to actually peek into the stream of events that are being sent by that simulated device to IoT Hub. So what you can see here, my cloud diagram and my jobs are still listening to the data. They're also listening. So you can, with multiple people with the right security, of course, you can listen to that same set of streams. So you can see what's coming in is just a JSON structure with a device ID, a temperature, the humidity, external temperature, which is null, and some basic properties. That's the type of data that is being sent by that simulator. And you can see it's just constantly getting added. Okay, so that's the IoT Hub in the back. If I would now, I don't know if I can actually do that, but maybe with an update. No, it's probably only through the, I could, for example, change the key, but I could also set it disabled. That has to be done by the API. Then the device will be blocked. So that again, if someone would hack my device, I will just block that specific device through the API, and it will be stopped from sending data to my cloud. Okay? That was the IoT Hub part. A tip to save some budget. So you've seen me creating everything in the portal here. And by the way, it's ready, but I will delete it already because it costs some money. But that's nice, I can just delete it and throw it away. But everything gets created in my portal with some basic settings. And for example, IoT Hub. Let me go and see, maybe this also could be if I'm fast enough before it gets deleted. The pricing and scale is set as a S2. And the S2 has 6 million messages per day per unit, and you can scale up to, I believe, 200 units without an issue. Of course, you pay for that. But typically, if you play with it, you don't need that. But this costs 10 times more, I believe, than this one. So what I typically do, if it's a development or a playground IoT thing, I switch it to an S1. That will cost less. Okay, but now it will be deleted in the back anyway. But that's the tip I wanted to give. So if you just keep the defaults, Azure IoT Suite, and you have like an MSDN subscription on Azure, you will see that the budget goes down quickly. What you can do with these things is save some money because that's what we all want to do. Now, we've seen IoT Hub for data coming in. We've seen the device registry is DocumentDB. The other thing is the event processors. So as soon as data is sent into IoT Hub, something needs to be done, and that's the stream analytics. Again, we've done a session last year on stream analytics, and you can see that there are 3 jobs created. The name sheet you've given, like Azure Belgium, and then device info, telemetry, and rules. Again, the tip to save money, just turn these off because they cost money if you keep them enabled. If you play with it, if you just test with it, turn them off. If you just tested telemetry, this one is the first one you typically turn off. That's just for new devices that that send their first list of commands and so on. You can enter that in DocumentDB as well. So that's one that I almost never use. So telemetry is one that you can keep for all your telemetry, and this of course is for the rules. But we're not doing anything. So again, just for demo purposes, it's easy to turn off. Now, the first rule we have is the device info job. So again, go back to the portal. What you will see, device info one, is that on the left, I have the stream of data coming in from IoT Hub, and on the right, I have a stream analytics, an event hub, and I have a query in between. So again, very quickly on what is Azure Stream Analytics. It's a very lightweight, but easy to use, complex event processing engine that listens on a stream of data or a combination of streams. It uses a SQL syntax, and it takes that data, and the data can be CSV, can be JSON, and can be, what's the other one, Avron or something. But it takes that data, and it outputs that data into something else, typically another stream, or DocumentDB, or Power BI real-time reports, or blob storage, and so on, or SQL Azure, and things like that. So it's incoming events. It filters these events, because this is just taking the events where the object type is device info, but you can also say, I will take the average temperature over a period of 5 minutes, and I will output that, for example. So it's a very easy to use syntax for streaming processing. So this one is just filtering out the device info events, and that's the one that I said in the beginning. That's the list of commands that my device is using. It says, you can ping me, you can brew beer me, and whatever. And it outputs them on Event Hub. Event Hub is, as I said, similar to IoT Hub. Why is it doing that? This will be a limited thing, and it's like a queue. It acts as a queue, and the rest is handled by this thing. The web job, the one that I showed, the action process, or the device info one, is listening on that Event Hub. And as soon as a new device sends his information, it picks it up, and it updates or adds the data into the DocumentDB. So in the beginning, if I go back here, my document MTB was just that. That's the initial document where the comments were empty. And after the job, this job did his action, you probably remember that the list of comments and so on was added. And that was by that job. Okay? Questions so far? Now, the next one, telemetry job, and that's the copy pasting. It's used to process telemetry events, not the rules and alerts. But what does it do? It does two things. The first one is very easy. Select star into telemetry from stream data. So that's every event that has a telemetry event will be written one-on-one to the right, and that's a CSV blob. So blob storage, you probably know that's like a file storage in Azure. The second thing it does is also take some averages and it writes it to another set of blobs in another container. And here you can see it's more, complex, but also easy to understand. And as I said, it's the average of the humidity, the minimum of the humidity and the max of the humidity. So it takes these values and it takes, of course, the device ID. And this is the interesting one, by a sliding window of 5 minutes. So it's a window of 5 minutes, and every time a new event comes in, it takes the last 5 minutes, takes the averages, and updates that to the blob. That's how you should look at it. You have tumbling windows and other things like that. Again, details are in the, I think, the recording of the stream analytics thing. But that's the type of job that writes more summary data into the device telemetry. And if we go back to this portal, you should see that that's the max, minimum, and average. These are the values that were shown there. That's on the blobs, but I will talk about that later on. Okay, so that's the telemetry stream analytics jobs. The other one is the rules. So I didn't show how that works yet. What I can do as well, if I have my device, for example, let me create a new one, a real device. So a custom device, Azure simulation 2. I'm creating it. Now the how's it called again? The job that is doing all the processing, the simulation job, will not do anything because it's not a simulated device, so it will not start sending data. So I can update that data myself. But what's important is that I can add rules to this device. If you're a little bit patient with the Wi-Fi, is the stream doing well? We can also blame it on the portal then. It's not my fault. That's that's the umbrella thing. Where's document DB here? It has to be enabled first, so that's why I'm going back to document DB. So this is my created device, so I have to enable it myself, or the device should send it its own information, but you can also just update it in the document. So I will just mark it as enabled. Save it here. You can see it's now running, and I can add a rule. Again, the rules here, you would expect that things are much, in a real solution, I can do more than just fixed grade. I say it's not a real solution. So I can take the temperature and the humidity, and I can say if the temperature is above, let's take 34 centigrade or Celsius, we will do an alarm of the temperature, and I will save the rule. So now I have a rule created for the simulation 2 device that is enabled, and it says if the temperature is larger than 34, you should trigger an alarm, right? That's my rule that I have now linked with this device. Now what's happening in the back? In the back, this device rules, that's a file that is living in storage. This file is being updated with a new record. So it has now, instead of coded simulator, it has Azure Simulator 02, temperature 34, rule, blah, blah, blah. So it has that as a reference file. So now the stream analytics job takes that file with a stream of telemetry. It merges them together, and there's actually some kind of a join. And I left the query out. I can show it in the portal. But in the end, it does select of the values that are larger than device rules. And if there's something, it outputs them to the rules output in Blob and also to the event hub. And that's the same thing that you saw from before. There's a web job that listens for all the alarms. If there's an alarm, and the method, if you look into the source, the method is execute logic app. And if you then look into the that specific method, let me maybe see. I'll search for not implemented. That's probably the easiest way to find it back. No. Oh, I won't search for it, but you can see that they don't do anything. The idea is that if there's an alarm, you could trigger a logic app. And if you didn't hear about logic app, a logic app, you could look at it as some kind of a lightweight workflow where you can drag and drop actions. So you could say, I trigger a job, and that job will send a text message, will send an email, in the SAP system, whatever you need to do. So that's the thing that they want to show here as a reference. Okay. I don't think it's needed that I dive into the details of this specific query, looking at the time there. But what I also believe that you should add in a real world, some kind of a tumbling window, because now what happens, they listen, and as soon as one event in the stream is larger than that threshold, they output something to this whole thing. I don't believe if you're sending emails or something, I don't believe that's something you want to send, constantly. You say, if it has been 2 hours ago since I have sent my alarm and things like that, and you just send a second one. So, but that's logic where you can use the SQL syntax for as well. Okay. The presentation layer, that's least of my experience, let's say, but the presentation layer is actually using behind the scenes Power BI controls. So this, and this, that's all Power BI controls that are real-time updated. So if I go back to the simulation one here, you should see that this is, if you wait, I believe it's every 20 seconds. It's a very secure solution as well. Typically, you will see that moves, and it's a real-time graph using Power BI. Right? Again, this portal is totally open sourced, so you can update things. It's using some kind of best practice things. I did some basic customization. Here's the blue. That's how far I could go, and I don't have access on that one. But that's the whole presentation layer that you get added there. Okay. What you can do as well for the save costs again, for the website, for your web jobs, they're running an app service plan, and an app service plan is linked with a tier. You have S1, B1, and things like that. Again, you can change the tier if it's just for playing. Just minimize the tier to something. I believe you could even go to a free thing. It depends on the features you need. Okay. Now, to wrap up, what I want to do is I want to show something more live. I was planning to use my private lights. The thing is, we don't have connected cable yet, so and my Wi-Fi didn't work yet. So we'll have to do it with a simulated thing. And that should be in the shortcuts. So I have a simulation tool, and the only thing I need to do before I start up is I need to enter the name and the key for that device. So this is just the app config. So what I will do, I will take the device that I just created, Azure Simulation 2. I will take that device. I go to the authentication keys in the right, and I can take this copy. And since this is a recorded session, I will make sure that I revoke the keys after the session, because you never know. Actually, I always say that, and I always forget about it. So please, someone remind me afterwards. Oops, copy. Yeah. So you can see I just updated these things. If I now will run the tool. Whoa. Let's go in full screen. So it's like a simulation. If I start doing the play, the enable, every 10 seconds, the values of the temperature and the humidity will be sent to the IoT Hub. Shout out to Jorn for creating this tool. And here I have some actuators. So I can start the fan, I can turn up, do the blinds up and down. So it's like just a very basic simulation thing. Now, if I just start sending, and I will change the interval to, why not every 2 seconds. I'm expecting in the dashboard here, I can see that I'm around 40 and I'm around 20, I assume, for the values that I'm sending. So if I now increase the value of my humidity, you can immediately see that the value of the graph gets updated, as well as these the summaries. So all the jobs are constantly running, updating the blobs, and Power BI is automatically updating this thing. Remember that I have a rule. The rule should appear here as soon as the temperature goes above 34. Someone, yeah. So let's try to simulate that. So I'm expecting this to have, auto-updated every some seconds, and it should show that the rule exceeded. At least that's what I hope, if my job is running. Let's have a look. I just think I'm not patient enough. But rules. It's stopped. Let's do a start now. I'm expecting to see this, and it will. That's why I said they are not doing a tumbling window. So I'm expecting here to have a lot of entries. As you can see, I tested it some time ago, and I will get more entries at the same time. And all of these entries are triggered into that event hub and are being sent out to that logic apps as well. So you can see here now that the coded simulator has an alarm temperature. The value was this, so it's larger than the value that was configured. Oh no, that's still the old one. Sorry. Okay, let's be patient for that one, or increase the value again. The next thing I want to do, I want to send a command from the portal to my device, right? So what I need to do there sheet. I need to enter the set of commands that can be executed. After that, I go back to my DB. I will have to copy it from another one. Streaming job has now started, so it took a while before the job started, it seems. So if you go to the Document Explorer, demo command, a sunscreen command, a fan command, and a humidify command. I'm copying that, and I will now copy it to the ASIC simulation 02. That's my device, the one that I have running now. I will just save this thing. The rules are still not. Forget about that. If I now click on commands, to get a list of demo command and things like that. So if I now want to simulate the sunscreen command, I can send an action up. So the sunscreen is this thing on the bottom left. So I'm sending the command, and you can immediately see that the command has been received. Of course, this looks easy because this is a PC, but that same protocol would work if this would be some kind of Raspberry Pi or embedded OS or real-time OS, whatever you have, running somewhere with just an outbound internet connection, because that's the AMQP protocol. Again, a lot of details can be found online. It's not my intention to have a full explanation there, but you have real-time commands, semi-real-time, and you also have feedback from here. So that's also something that's important in IoT solutions. If you execute a command from in the cloud, it's important to know to get feedback from the device if it was able to receive and to execute that command. Imagine that you have something to remotely lock your door or something, like you open the door for someone to get in remotely, and that succeeds, and then you close the door, but that somehow gets lost, that command. You want to know that. You want to see the command was not received or handled in 5 seconds, depending on how you configure it. And you want to retry, or you want to be notified. So that's definitely logic that has to be thought of as well. And that's why you can see there on the result, it's pending. I believe if I do a refresh here, it's changed to success. So it's important for your history to keep track of what succeeded and what not. Let's do one more thing. The fan command, that's probably an on. And there we have the fan starting to turn. Okay? Any questions so far? All right. Let's have one last look to see if the rules got updated, because I really believe that should be the case. And yes, they are. So you can see now 7:30, and you can see they get updated frequently every time that a value gets exceeded. So let's decrease this one again by 30. You should see that the graph here drops again, and that will stop here with with sending data. So I believe it's a good overview of what Azure IoT Suite is. I want to wrap up. I think I talked about that mostly, so let's skip that. But I want to wrap up with how we should position it. Not like some people, including some people in Microsoft, think, not like a ready-to-use solution. We will not go live with that because it only supports humidity and Celsius, humidity and temperature. In reality, you get much more complex values and much more details. Real IoT solutions. So what is it for me? It's good for prototyping, to start playing with the UI, with stream analytics, with all of these things. So with a matter of clicks, you have a solution running you have all the components there, and you can start playing with it. You can dive into one of the components of your preference, and you get a good idea on how things are built. So it's also ideal for quick solutions, for quick demos. You go to a customer, you want to show something on Azure IoT. This is something you can easily set up, and you have something easy and quick to show. Just don't give them the impression that it will be very easy to build the full solution they want, because that's not the case, right? And it's also an interesting reference architecture. I mean, it's fully open source, so you can just go to GitHub, Azure IoT, GitHub, somewhere. I believe it's Azure IoT Remote Monitoring. This one. So you can just get the full solution there. It has the web jobs, it has the simulators. So it's an interesting thing to look into. You have the portal, you have the real-time Power BI jobs that you could be of benefit for you. Even if you're not building IoT solutions, you can definitely have a look at that code. So what's missing in this solution to get the real thing? Yeah, cloud-to-cloud messaging. So as I said, if LoRa or Sigfox or whatever you have, if those cloud devices need to send data, typically they won't send over AMQP or things like that. Typically that's more API to API. So that's definitely something that's not there that we built ourselves. The same thing with activation and provisioning. So if you have a device, if I'm a manufacturer of solar panel, what I'm expecting is that if the solar panel gets plugged into the network, that everything is secure, so that I have to first enable that device. I'm the installer. I have to enable the device with my app or something in the cloud. I say, I will now plug in the device with this, I don't know, QR code or something. So in the registry, we prepare the device, and then the first call home or bootstrap or provisioning endpoint, it depends on the terms you use. That's the first call that the device will do. It will say, hey, I'm here. It uses a secret hidden key, typically burned into the silicon, and it sends that key, and it will have to match. It has to see, oh, that device is now ready for activation, and then it gets the values back from the registry, so from the IoT Hub. Then it gets the values from the device ID, the device key, where do I have to send my data, and so on. And that's what you have to think about in the activation and provisioning. Flexibility and parameters and rules. So it's just humidity, it's just Celsius. You can use greater than or larger than. So that's not something you want to have in the real world. And the backend integration is also not there. So all the code is written, but the code where they need to call the logic app, that's not implemented. So you have to fill that in yourself. One thing that's also not included, and that I believe is missing in the Azure IoT offering in general, is updating of devices. So we work with customers, and it's very easy as long as the device is in the lab environment or in a home that you have under control. If something is missing, if you need to fix something, you just go to the device, you upload the new software, or you connect to it. But as soon as that device is in the box and it's shipped to retail or wherever, it's out of your control. The only way you can reach your device is through that cloud connection. So that's one of the things, one of the patterns that a lot of times are quite complex to set up. So typically you need to send a comment like, hey, there's new firmware, and that device has to be able to update itself. And yeah, it depends on the operating system of the device and the code of the device in order to see how it does that. Right? So typically you send a command and it goes and asks and downloads the firmware, and then it has to update itself. So we did something in .NET Core, so the new open source cross-platform .NET to do that. But we have a customer who has that real-time operating system thing that they have to do it themselves, and they also have to download that image and restart themselves. And that's the complex thing. If your device is shipped, the only way you can update it is again through that existing cloud connection. Okay. So I think that's around 1 hour. thanks for listening. If you have questions, I would say shout. Otherwise, I think we have a small break. Grab me if you need some information. And otherwise, I'm looking forward to the next session on, I was going to say Spark, but it's Storm, right? Yeah, thank you. Thanks.